Assalamualaikum and a very good day to our panel. My name is Farid bin Habibul Mutsidin from AS229. Today I will be presenting my final year project entitled Noise Exposure for Residential Area in Section 2 Shah Alam. This study is about noise, which is a common environmental risk, and it comes from various sources such as road traffic, construction activities, commercial enterprises, and many more. And according to Moro and Mabaso 2022, among the various sources of urban noise, vehicle traffic is the major contributor. So this study will explore noise pollution in the selected residential areas in Section 2 Shah Alam, and it will focusing on traffic flows impact on the noise levels. This is the problem statement for this study. First, excessive noise in residential areas significantly impacts residents' well-being and quality of life. Road traffic is identified as a major contributor to environmental noise, involving complex factors like engine noise and tire interaction. Secondly, noise gives physical and mental effects on individuals. And lastly, emphasizing the importance of addressing noise exposures for improved health, sleep concentration, and overall living conditions. Comprehensive research and effective noise control measures are needed to create quieter and more peaceful residential environments. These are the objectives to achieve in this study. Firstly, to determine the noise level in residential area section 7 Shah Alam. Secondly, to identify the traffic volume and traffic composition during peak hours at the selected location. Thirdly, to analyze the relationship between traffic volume and noise level in the residential areas. There are three crucial research questions for this study, which are how to determine the noise level in residential area section 7 Shah Alam. Next, what is the flow of vehicles along the roadside during peak hours? And lastly, is there any relationship between traffic volume and noise levels in the residential areas? These are the literature review for this study. First, Story 2020 stated that noise is defined as the unwanted, unpleasant, or loud sounds. Next, Might al 2020 mentioned that human health and welfare can suffer from psychological effects resulting from noise, including annoyance, sleep disturbances, hearing loss, cognitive impairment, and also mental illnesses. After that, Hamin et al. 2021 stated that the maximum allowable noise level outside of low-density residential areas at suburban and residential areas shall not exceed 60 decibel at daytime and 55 decibel at nighttime, in accordance with the environmental regulations established by the Malaysian Department of Environment 2007 in order to safeguard the community from this urban noise. And lastly, a study conducted by Segaran et al. 2019, it shows that due to the high level of traffic, the noise from the road creates obtrusive sounds that bother the surrounding nearby residents. They also mentioned that Malaysia experiences noise pollution issues, much like other growing nations. This is the table for recommended permissible sound level by receiving land use for existing built-up area as stated in second schedule of Department of Environment 2019. As for the methodology, first of all, I chose three different residential areas in section 7 Shah Alam. First, Jalan Tumalin. Second, Garden Villa. And third, Crystal Harmony. For the instrumentation, I used the sound level meter to measure the noise level for each location. And for the parameter, I look after the LAQ, LAS max, and also LAS minimum. And after that, for the measurement level, I did 3 measurement sessions for each locations during weekdays, which is early in the morning, during lunch break, and in the evening. Next, I chose 2 stations for each locations to effectively identify the noise level. Furthermore, I am using short-term sampling method for this study in accordance with the Department of Environment. The measurement was running for an hour with 15 minutes interval for each measurement. And then for the traffic volume, I use the count clickers to measure the traffic volume. After that, I use the SPSS software to analyze and examine the relationship between traffic volume and noise level at various times of the day by using the Pearson correlation test. To assess the relationship between traffic volume and noise level in different time periods, a bivariate Pearson's product moment correlation coefficient was calculated and recorded using SPSS. This is the data for traffic noise assessment for each locations. We will focus on the LAEQ value as it shows the equivalent continuous sound pressure level over the measurement period, which is the average received sound energy over time. I put the maximum and minimum value because it is advised by the Department of Environment just for informational purpose because it only indicates the highest and lowest level during the measurement period, not the average. For better understanding, we will look into the graphs. The graph illustrated that noise levels vary significantly depending on the location and time of day. For example, the noise levels at Garden Villa were consistently higher than those at Jalan Tumalin and Crystal Harmony. This is because the road at Garden Villa is a bus road, especially for students, and also there are construction in progress right there, so the heavy vehicles are using that road. Additionally, according to Young et al. 2020, noise levels were generally higher during peak traffic hours, particularly during the evening rush hour. After that, we can see that as for Crystal Harmony, it has the lowest noise level because it is isolated from the main road. Moreover, we can see that among the locations, Garden Villa is the only location that exceeds the permissible noise limit that's set by the Department of Environment under second schedule, which is 65 decibel. So this is certain to have negative impacts on the residents. This is the table for the traffic volume data, and we will look into the graph for a better view and understanding. This is the graph of traffic volume for each locations. As we can see, the traffic volume also varied across different locations and times. For example, Jalan Turmalin had a high proportion of cars and motorcycles, while Garden Villa had a high proportion of vans and lorries. That is why Garden Villa has the highest noise level among those three locations, and Jalan Turmalin is the second highest. After that, this information is important for understanding the sources of noise pollution in different areas and can help inform potential noise mitigation measures. One potential implication of these results is the need for targeted noise mitigation measures in areas with consistently high noise levels. For example, efforts could be made to reduce traffic volume during peak hours, such as through the implementation of carpooling or public transportation initiatives. This is the statistical value that I did to determine the relationship between traffic volume and noise level between different time periods. First, the Pearson correlation coefficient for traffic volume and noise level during the morning peak hours, which is 7 a.m. to 8 a.m., was found to be 0.947. This high positive correlation indicates a strong linear relationship between the two variables during this time period. As traffic volume increases, there is a corresponding increase in noise level and vice versa. After that, for the afternoon peak hours, which is 12 p.m. to 1 p.m., the Pearson correlation coefficient was calculated to be 0.737. This positive correlation suggests a moderate linear relationship between traffic volume and noise level during this time frame, while the relationship was not as strong as in the morning. It still indicates that changes in traffic volume are associated with changes in noise level during the afternoon. And lastly, During the evening peak hours, which is 6 p.m. to 7 p.m., the Pearson correlation coefficient was notably high at 0.988. This extremely strong positive correlation signifies a nearly perfect linear relationship between traffic volume and noise level in the evening. And the data suggests that as traffic volume varies, there is an almost identical variation in noise level during this time period. So, for the conclusion, the Pearson correlation test reveals significant positive relationships between the two variables at different times of the day. These findings can provide valuable insights into the dynamics of traffic-related noise and can be instrumental in understanding and managing environmental noise pollution. To sum up everything, the experiment successfully determined the noise level in the residential area, providing valuable data on the acoustic environment in Section 7 Shah. This information contributes to our understanding of the ambient noise in the locality. Next, the assessment of the flow of vehicles along the roadside during peak hours was effectively conducted, offering crucial insights into the traffic patterns in the area. This knowledge is essential for urban planning and traffic management considerations. Lastly, the investigations into the relationship between traffic volume and the noise levels in residential areas yielded meaningful results. Identifying such connections is vital for developing strategies to mitigate noise pollution and enhance the overall quality of life for residents. Finally, for the recommendation of this study, and to mitigate the problem, we can use soundproofing in homes by assessing the level of sound insulation in materials utilized in walls, floors, and various building elements. Empowers the designer to establish the permissible degree of sound insulation achievable through the utilization of specific materials. This process aims to create a comfortable acoustic environment. Next, by doing traffic management. By implementing traffic calming measures such as speed bumps, roundabouts, or traffic islands to reduce vehicle speeds and noise. Lastly, by installing the noise barriers like noise walls or fences along busy roads to block and absorb traffic noise. Okay, that's all for my final year project presentation. Thank you.